Welcome back to 3R Ballistics. Today's Outcast Science is going to be barrier testing or material testing, however you want to say it. We have fiberglass. We have e-glass. This is the particular type of fiberglass we have, which you've seen before on the channel. This is woven roving. This is an 18 ounce. We usually do about 25 layers. That makes it level 3A. It could stop a 44 Magnum. And we want to see how much fiberglass we need to stop a rifle round. And what we did was we put a bunch of these together, 4 actually, and came up with this. We want to see if this will end up stopping rifle rounds. And to compare that with, we ended up getting some of this. It's actually circuit board material, but I did a lot of research, and what I found out is this is made with S-glass, type S-glass fiberglass. It's only a 3 ounce fiberglass, but it also has phenolic resin, which is a very impact resistant resin. We have the same thickness amount in this to see which one handles the kinetic energy of the rifle rounds better. So let's go ahead, set these up and start shooting. Here we go. We're going to start with the 55 grain full metal jacket in 5.56. We will go upper left or just left. Oh, I forgot to turn the chronograph on, but we can assume that was going about 3,100 feet per second. Clear. So here is the 55 grain full metal jacket. Did not go through, so we are going to try 7.62 by 39. It's a little bit has a little bit more energy. Let's see if that does it. Okay, now we got the 7.62 by 39 123 grain full metal jacket. Got the chronograph on this time. Let's see how fast it goes. Try to go a little bit higher in center. 2399.5, so 2,400 feet per second. Clear. So right here is the 7.62 by 39, and nope, nothing has gone through yet. Looks like made it about halfway. So definitely time to try the 308. Okay, so this is what we're here to actually see. Can standard, just woven roving fiberglass stop a 308? This is 7.62 by 51, M80, 149 grain. And here we go. Try for the lower right side. You ready? 2,849.6 feet per second. So that one had quite a bit more energy, but the question is, did the 308 go through? It did. It did. It's right there. We stopped it right there. So we have one more plate to put on the back of this. Let's see if an 1 3/4 could stop 308. Okay, so we added one more panel, which is 25 layers more of fiberglass, which ends up being a total of 1 inch, 1 3/4 of an inch thick. So let's see if that can stop the 308. Okay, here we go. Ready?
Ready.
Speed 2,813. Clear. Okay, so this is the 308 that we just shot. And here's the extra panel. which looks, look at that. Did not go through this extra panel. Stopped. We had lost significant velocity and energy even with this one. As you can see, most of the metal is right there from the 308. That's where it hit. That was a different shot that we did. As you can see in the one that went through, hopefully it kind of clears up. It went 2 inches into the clay. So it did go through this other one at 1.25 inches, but not through this one. All right, let's try the S-Glass. Let's see how much more durable the S-Glass or weaker the S-Glass might be. Okay, so we put the phenolic S-Glass board up there. We have 1.25 inches of it. We're gonna start with the 55 grain full metal jacket out of the 5.56. And right below the strap. Speed 32.19. That is flying clear. Okay, walking up to this, I could tell you right away, it is already braking in a different fashion than the S-Class. But it stopped it much shorter. Interesting. Well, let's move on. 7.62 by 39. Okay. 7.62 by 39, roughly traveling 2,400 feet per second. Okay, here we go. 24 feet per second, clear. Well, there's the 7.62 by 39. And it tore the tape that we were holding it by. Holy smokes, that is interesting to see. So it stopped it easily by the second layer. This is going to be really interesting for the 308. We'll probably retape it and see what happens. Okay, here we go. 308 M80. I'm sorry, 7.62 by 51 M80 149 grain. We retaped the S-Glass, turned it upside down, try to shoot it towards the top. Okay, here we go. Speed 2,839. Clear. Walking up to this, it blew the retape off, and that is the 308 right there. Did it go through? Oh, I don't think it did. That is an indentation. That is a break. You see lead. But what the heck did it? Oh, it's falling. It is all falling out in there. It is at the bottom of the S-Glass. So what it looks like is that even though it broke, none of the projectile actually went through. Very interesting scenario. So you guys tell me in the comments, is that considered a penetration, or is that just the deformation?
Okay, back at the shop now, and we're gonna tear these panels apart. We're gonna go ahead and start with the E-glass. But what I want you to notice is that there is very little delamination or falling apart of the panels. These panels could have taken quite a few more rounds and held up just as well. That being noted, they worked kind of like a hybrid system. Metal will break up a bullet, composites will catch the bullet. This fiberglass kind of worked in both ways. It broke up the bullet and caught the bullet. It was hard to find any of the projectile left because it did break up the bullet. As I tore these panels, the layers apart, there was just lead shrapnel and some copper jacket here and there, but there was no complete projectile left to pull out. So it works kind of like a strike face in body armor, where it breaks up the projectile. It also slows it down. It's a little ductile and can bend and absorb some of that energy. So I'm pretty pleased with the way the E-glass ended up working. It did take about 1.5 inches of material to completely stop the 308. But that being said, again, I mean, for the ease of use and the ease of putting it together, I was extremely happy. And there are the 5 panels that you see that we used to stop the 308. And for those that are curious, I think roughly 115 layers of woven roving should be able to stop a 308 no problem. Now, moving on to the circuit board, terminal board material. This broke up the projectiles a lot more. I mean, there is nothing there. It slowed it down. This was more like a strike face in a composite strike face body armor material. As you can see, the 556 was broken up in the first panel. The 762 by 39 and 556 didn't even make it past into the second panel. And then the 308, you know, like I said, most of the projectile, you can see the copper right there, the copper jacket. Most of the projectile was broken up, but I kind of leave it up to you guys. Let me know. Do you consider that there was no lead that had passed through? But, you know, is that still considered a pass through?
So in conclusion, there are definite advantages to the E-glass and to the S-glass. I will bring up the most obvious upfront: price. These terminal boards, circuit boards, whatever you might want to call them, structural boards, this G7, this piece right here is $50 if you were to buy it. Now, I was fortunate to get some drops, and they didn't cost me quite that much. But at 10 millimeters thick, this board right here, they're expensive. Now, if I were to compare the raw material, which is the E-glass in woven roving and the S-glass in a plain weave, they are similar. The S-glass is more expensive, but it's a lighter weight. It's a 3.5 ounce versus an 18 ounce, which, I mean, just doing the math, you'll need, you know, 300 layers instead of 100 layers. You'll need 3 times the amount of material, and just to try to get the same ballistic performance, if not better. I mean, S-glass is stronger. We saw in the video, it's stronger, it's stiffer, and it resists more material. So you can go a little bit thinner. We plan on doing something like a shield or other armor testing. Maybe we'll throw it in a suitcase and show you, you know, how it can perform with and without the panel. But it gives you a lot more options to avoid certain rifle rounds. And now we know, you know, it takes about 1.25 inches to stop a 308 in woven roving, and about a little more than 1 inch of the Type S glass. We have some more coming up for you. We haven't forgot. So until the next one.